Hi, my name is Andrew Kim, and I will be walking you through abstraction and encapsulation, which are two concepts in object oriented programming. And abstraction really is just an idea of providing the outside world with only the essential information. For example, look at a book. When you hear the term book, you don't know the exact specifics. You don't know the page count, you don't know the color, you don't know the size, but you understand the idea of a book. So, the concept of abstraction is that we only focus on the essential qualities rather than the specific characters. So, for example, when we mention a book, we want to create an abstraction of the book. We will think about its color. We will think about something like its page count, as I have mentioned, and we will also think about the size. And this idea of a book, it could be many books, so we can't have like a class for every book. It would be tedious to have a class for every book, but we can have one class, and then we can allow now the specific type of books to borrow from this class. So the idea of data abstraction, you achieve it using abstract classes. So it's a class that if you want to use it, you have to inherit from another class. Or simply put, if I create an abstract class, the only way I can use it is by extending it, by borrowing from it. That means I cannot implement or I cannot instantiate an abstract class. Let's jump into a quick example. So, for example, we can have an abstract class of animal. Just like book, we have the things, we have qualities we know about an animal. For example, we know that probably most animals have legs, and they probably make a sound. We can say that those are probably a property and a method. So I would create an abstract class called animal, and then I can probably have an integer there called legs, and then I set that to 0, and I can have a method called make sound, just to match what we were saying. Sorry, this should be this. Yeah, so to match what we were saying above. Yeah, I think that's okay. So this is an abstract class, so we cannot implement this class, but if we maybe created an animal like a cat, we can do we can create the class, and then we extend from animal, and then we ensure that we have to implement all methods. As you can see this error, there's a missing concrete implementation of animal.makeSound. So ideally, when you inherit from an abstract class, you have to implement all the methods. So for example, I can just create one missing override, and then I implement that method there. So a cat makes a sound, you can just print to the screen something like meow. Yeah, that should be good. So we can print meow. So we have created an abstract class called animal, and we have extended the abstract class with another class called cat. So now, for us to get the sound, we just have to go to our main method, and we create an instance of cat. So cat, my cat equals to cat, like that. And then we can now call my cat.makeSound. And then if we run in the debug console, you will see that it prints meow. So ideally, that's abstraction for you. That's one example. I also created another example for example, this class is called subject mathematics. It's an abstract class. So in a school, every class, a class is usually composed of subjects. If you look at a timetable, so this particular class, maybe like class 4A, will be having these subjects. So we have this one subject called subject mathematics, and we are going to have many students in this class. So we cannot really implement this class, or we cannot create a subject mathematics class for everyone. So in the idea of making our code cleaner, we create a subject mathematics abstract class, and then we have two methods here: student performance and then student conduct. So student performance is going to take an int grade, and conduct is going to take in a message. And any class now that extends from this subject mathematics class will have to implement these two methods. And I have an example now. In the mathematics class, we have many students, so you create another class, student, that extends the mathematics class. And when you're instantiating that class, we have this constructor that you're going to pass in the student name and the admission number. And now this is student performance, a method that is present here and needs to be implemented here. So it's taking the grade, and then if the grade is greater than 50, it prints this message, else it fails. So that is the performance for this particular subject. And then also we have this student conduct method that takes in a message, a string parameter, and then if the teacher has said that this student is good, we print good student, else we print do something. So now in the implementation of this class, we are now implementing not the abstract class, but we are implementing the class that extends from the abstract class. So students, Andrew Kim, this could be anything, could be something like var or whatever, but I choose to use students because we're actually just creating an instance of student. As you can see there, so student Andrew Kim. So we create a student, and then we pass in the first parameter, which is the name, and the second parameter, which is the admission number. And then now we access this method called student performance, and we pass in 43, which is the grade. And then if you look at this logic, we expect print fail. So let me just run this, and it says fail. So that is ideally how an abstract class works. Now let's jump into encapsulation. And ideally, I want you to think of a capsule. I'm sure maybe at some point you've taken medication and you've taken a capsule. And usually a capsule usually has an outer covering. An outer covering, just imagine it, an outer covering, and then we have the medication in the inside. So encapsulation means we are putting some methods or some properties inside a covering. Like the medication in a capsule, we have some methods and properties that are inside, that there is limited access. In other languages, you will see keywords like public and private, which essentially explain the idea of encapsulation. So for example, if a method is public, it means that it can be accessed by everyone. But if it's private, it's like that medication in a capsule that cannot be accessed by everyone. So in that, we don't have the keywords of public and private, but we do have this underscore, and you'll find it also in Python, which is used to mark private members. So this, you could say here, it's a private member. You still can access it, but when another developer looks at your code and sees underscore and then the name of the property or the name of the method, they know that this is a private member and it should not be accessed outside this class. So essentially that's what encapsulation is. You just use underscore to tell people that this particular property is not supposed to be accessed outside this class. If you look at our example, it's a bank account, and a bank account probably will store a PIN. And the reason why this is a private member is because, of course, pins have a particular level of privacy. Not everyone should see, the PIN of someone. So here I have implemented a private property to store the PIN because it has privacy properties. So ideally that's how you choose whether or not a property or a method is private. So essentially that's it on abstraction and encapsulation. Be sure to practice, be sure to read further. Thanks, and I'll see you in the next video.